Nope, not that one. Not the one. No, not that one. This one. Okay. So today we're going to look at volume of pyramids. So, like I said before, we looked at volume of prisms, and today we're going to look at volumes of pyramids. So, just to remind you about volumes of prisms, the way you find the volume of a prism is you want to identify the area of the base and then multiply that by the height. Okay? If for some reason you have an oblique pyramid, you're going to use the oblique height. But if you have a normal pyramid, you're just going to use the normal height. So the first thing we're going to do is we're going to go ahead and identify the area of the base. We notice here that our base is a triangle, and so we want to use the area of equation for a triangle to find the area of a base, which is 1/2 base times height. We have 1/2. Our base is equal to 6, and our height is equal to 5. So that's 1/2, 30, which is equal to 15. So that is our base area. Now we want to go ahead and identify our height. We can see here that our height is equal to 8. And so now we have 15 times 8, which is 120. And so that would be the volume of this prism. Okay, so that's how we find the volume for prism. Today we're going to go out and figure out how to find a volume of a pyramid. In general, we use this equation, which is 1/3 the base times the height. Okay, but let's just go over some general characteristics of pyramids. More specifically, we're going to look at a right pyramid in this example. Just a reminder that the base, a pyramid only has one base. So in this instance, our base would be that square or rectangle looking figure right there. Then we have a base edge. The base edge is going to be the sides of the bases. So these sides would be our base edge. And I know I'm not doing it perfectly, but those sides would be our base edges. Okay. Then we have our lateral faces. Our lateral faces are going to be any sides of the pyramids that are not the base. So we have in this example 4 lateral faces, and these would be the lateral faces. Those triangle looking faces. Okay. Then we have the apex. The apex is going to be the top part of the pyramid. So that right there would be the apex. Our height is going to be the distance from the apex perpendicular to the base. So in this example, this line right here would represent our height because it goes from the apex perpendicular to the base. So that would be our height. And then we also have what is known as a slanted height. And that's going to be the height of the lateral side. So, for example, this could represent that height of that lateral side. Okay, so those are all different characteristics that we have of pyramids. So keep that in mind as we're going to look through a variety of different pyramids today. Okay, so how exactly do we find the volume of a pyramid? Well, again, we're going to use that equation that is 1/3 the base times the height. So we want to identify the area of the base and multiply it by the height. So 1/2 the base area times the height. Just a reminder that your base area equation will change depending on what kind of base you have. And so here we have a right square pyramid. So we have a square. We can identify what the volume of the square is by taking length times width. In a square, all the sides are equal to each other, so 6 times 6. 6 times 6 is 36. So that would be my base area. And now my height. So it tells me my slant height is 5. And my base at length is 6. And then so the height of the pyramid is the distance from the apex to the center of the base. And it is perpendicular to the base. The slant side is going to be the altitude of the lateral side, not the height of the pyramid. So when we're looking for the height, what we're looking for is not the slant height, but we're looking for this height here in the middle. This height, which is perpendicular to our base, because we have a right pyramid. So whenever we have a right pyramid, we want to use our base, which is that one, which is perpendicular to the base. Okay? The way we'll find this here is we'll identify that that forms a right triangle. And we know how to identify the missing sides of a right triangle. We use the Pythagorean theorem. So we're given our hypothesis, which our hypotenuse, which is C, and A and B are interchangeable. So A squared plus 3 squared equals 5 squared. Subtract 9 from both sides. To the square root to eliminate the square. A is equal to 4. Now that I know is A is equal to 4, that is going to be my height. So I'm going to plug that in. And remember, use the height that is perpendicular to the base whenever you have a right pyramid. And now 1/3 times 36 times 4 is going to give me 48. And so that would be the volume of this pyramid. Okay. Any questions about how I found the volume of this pyramid? Okay. So here is another example. Again, we want to use 1/3 times the base times the height. Why? Because we have a regular pyramid. So this is a pyramid. And what we have here is a hexagonal base. So whenever we do 1/3 the base times the height, I want to make sure that I'm using the hexagonal area for the base. Let's see what else it gives me. It tells me that my base edge is equal to 4 feet and the height is equal to 4. Okay. So let's go ahead and identify this. Give me 1 second. Hold on, guys, 1 second. Hold on. Okay. So now I want to go ahead and I want to identify the area of my base. So again, my base is a hexagon. So I want to use 1/2 base times height. Hold on. Okay. This is going to be equal to 2/3. Okay. So 1/2 my base is 4. My height, 2/3. And that gives me an area of 4 and 3. Okay. And so whenever I go ahead and put this in, I still need to find my area a little further. Well, when you look at this, what you'll kind of see is we can create 6 congruent triangles. This is 3. And so our area of our hexagon is going to be times 6. So 6, 4 to the square root of 3. And so that would give me my full area of my base. So basically, I found the area of one triangle, given the information that I had. Multiplied that by 6 because I have 1, 2, 3, 4, 5, 6. And so that gives me the area of my entire hexagon. Now I can go ahead and plug this in. I have 1/2 my base. My height, I was told, was 4. Right here. My height is 4. So that gives me approximately 55.426. So whenever I'm looking for the volume of my pyramids, what I want to look for is the area of my base and the height. And then I'm multiplying my area of my base, my height, times 1/3 for a pyramid. Okay. What about oblique pyramids? So like before we had oblique prisms, we also have oblique pyramids. An oblique pyramid is a pyramid in which the segment that connects the apex and the center of the base is not perpendicular. And so that means that whenever we're using the height, what we're going to use is this height right here. Okay? So oblique is kind of slanted, and so therefore the apex and the base are not going to be perpendicular, and so we want to use the height on the outside. So here's an example of that. This tells us directly that it is in fact an oblique pyramid. And then it gives us some information. It says the size of a regular hexagon base, so we know we have a regular hexagon base, has a measure of 5 centimeters. Sorry, hold on. Why does that keep happening? There, sorry. We're told the area of the base here already. And the distance from the apex to the center is 10 centimeters. So that would tell me that this side is 10 centimeters because it goes from the apex to the center. So this is 10 centimeters. And the distance from the apex to the center is 10 centimeters. Determine the value of the oblique pyramid. Okay? Well, first thing, we're already given our area of our base. And we know we use this equation to solve for the volume of this pyramid. And we're told the area of our base is 65, so we can just plug that in. Now what we want to do is identify the height. Well, what you'll notice is it looks like we have a right triangle which is formed, where this is 10 centimeters, this is 5 centimeters, and we're looking for the measure of our height. And so we can plug that into Pythagorean form. (25) plus B2, 100. 25 on both sides. B2 equals to 75. Get rid of that square. B is equal to the square root of 75. And so that would be my height. And when I plug that into the calculator, I get approximately 187.64. So here I'm given the base, and I need to identify my height given the information that is shown to me or given to me. Here is another one. This one says we have an oblique triangular pyramid. Find the volume of the pyramid. So again, in order to find the volume of a pyramid, we use 1/3 base times height. The first thing we want to do is we want to identify the base. Our base is a triangle, so we're going to use the area of a triangle equation. Our base is x. Our height is going to be approximately given what we are shown here. So therefore my base is, or the area of my base is this. Now I have the area of my base and I have my height, which is 2x. I put that together. Put that in my calculator and I get x. So basically, again, whenever you're finding the area of the pyramid, you want to identify the area of your base and your height, multiply those together, and multiply that by 1/3. If you have an oblique pyramid, what you're going to do is you are using the height on the outside, not the one that connects to your center, because the one that connects to your center isn't perpendicular, so that wouldn't be the accurate representation of the height. Okay, so in both of these, whenever you're identifying the volume of a pyramid, you want to use this equation right here. First thing, do identify your base. For a right pyramid, your height is going to be the one that connects the apex to the center. For your oblique pyramid, you're going to have the base, which is your normal base, but your height is going to be that which connects on the outer side of that pyramid. Okay, questions, concerns? I'm going to go over some more examples tomorrow, but if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.